plus create a meta, and highlight its significance, how it is being harmed and ways it can be protected. Ocean resources, fringing reefs. Part A. Significance of fringing reefs. 1. Fringing reefs protect shorelines from storm wave damage and also protect other important habitats such as seagrass beds, mangroves, and salt marsh. They are home to many commercially fished species, including coral trout, Plectropomys spp. And tropical rock lobsters, Panulurus spp. As well as many other spectacularly beautiful species that attract reef visitors. Because they are close to the mainland and are protected from rough weather, fringing reefs are important to the local economy because they are the most accessible and visited reefs in the region for both tourism and recreation. 2. Importance of fringing reefs to protected species. 3 separate sea turtle species: the green sea turtle, Chelonia midas, the hawksbill sea turtle, Erdemachli imbricata, and the flatback sea turtle, Natator depressus, are reliant on the surrounding reefs in the fringing reef region. Protected fish species that live in the nearby reefs include groupers, Epinephalus lanceolatus, hump-headed Maori wrasse, Chylinus undulatus, and barramundi cod, Chromoleptis altivelis. Since they are all reliant on reefs for habitat and food, the shells of giant clams, Tridacna spp. Helmets, Cassis cornuta, and trumpets, Charonia tritonus, are all protected mollusk species found on fringing reefs. While seabirds consume fish, a number of shorebird species feed on the nearby coral flats in search of a plentiful supply of invertebrate food. Part B. How fringing reef is being harmed. 1. Water flows can be impacted by coastal development and altered land use, which can affect the salinity, sediment, and nutrient movements, tidal flushing, and erosion of downstream coastal habitats. Water quality is decreased by runoff from land that has higher concentrations of sediment, fertilizers, and contaminants from human activity. Coastal oceans with more suspended silt have less light, which physically suffocates coral colonies when it settles out. Sediment can combine with chemicals and nutrients from agricultural runoff, sewage outfalls, and urban runoff, which can have a negative effect on coral settlement, growth, and reproduction. 2. Due to their location between land and sea, coastal coral reefs are very vulnerable to the effects of climate change, especially sea level rise, increased freshwater runoff due to storms and damage. Physical damage caused by waves in extreme weather events. The number of severe cyclones, categories 4 and 5, has nearly doubled over the past 3 decades in all ocean basins around the world. Climate change also threatens to increase the frequency of coral bleaching events. Corals depend on a narrow range of water temperatures, ideally around 26 degrees Celsius to 27 degrees Celsius. Temperatures just a degree or two above the normal local range during the season can cause a breakdown in the relationship between corals and indoor zooxanthellae, algae. Photosynthesis is a temperature-dependent chemical reaction. It accelerates at higher temperatures. As the rate of photosynthesis increases, waste products build up and damage coral tissue. Eventually the corals could no longer be obtained and they rejected animals from the zooxanthellae family. 3. Ocean acidification due to increased CO2 levels also threatens the survival of coral reefs. As carbon dioxide rises in the atmosphere, it also dissolves in seawater. In seawater, CO2 forms carbonic acid, H2CO3, which increases the acidity of seawater. Between 1751 and 1994, the ocean surface pH decreased from about 8.25 to 8.14. It may not seem like much, but since the pH scale is logarithmic, the acidity increases to almost 30%. The increased acidity of seawater weakens the limestone structure of coral reefs and also reduces the ability of corals to deposit limestone. Part C. Ways it can be protected. 1. Join a nearby conservation group. 2. Water quality starts at home. Remember that the chemicals you use at